we're going to look at a couple of more examples then of the increasing, decreasing, constant thing. And we're going to add a couple of more things just to make it interesting. Thank you, Keevan. I appreciate it. My toddler is helping me write this today, so we'll see how well this goes. All right, so say we've got a point over here at 0, 0 on this graph going up. And then over here at 0, 2, we've got a point going straight to the left. Excuse me, got it going straight to the left. This might not work very well. All right, we've got a point going straight to the left. So again, I'm going to ask, well, where is this function increasing? Where is it decreasing? And where is it constant? Okay? So where is this function increasing? Where is it decreasing? And where is it constant? So hit pause, see if you can figure this out, and then we'll explain it. Okay, so increasing, decreasing, and constant. So think about it. We're increasing where we're going up because, again, we're always going to read from left to right. Now, this is going to look confusing in a minute. Left to right. It's a good idea to draw a giant arrow underneath what you're doing so it's really, really, really clear what's going on. Okay, so we're going from left to right. Yes. So in this graph, we are increasing along here. Hopefully you got that. So we go out and out and out forever and ever and ever this way. So we're increasing from x equals 0. Remember, this is 0, 0. So we're increasing from 0 all the way out to infinity. Okay? Increasing from there to infinity. Now the next thing is, well, where are we decreasing? And actually here we're not decreasing at all. Toddler in the way. We're not decreasing. So you might say nowhere. Okay? And then the last question is, well, where are we constant? And so hopefully this looked reasonably constant over here. We're constant along here. Now the most common mistake to make here is to say that we're going from 0 to negative infinity. Because this is 0, right? This is x equals 0.
Come watch Thomas.
We'll come watch Thomas, yes. And this is x equals negative 2 infinity. Well, to make this example fast, I got to go watch Thomas, apparently. All right, so our x is going to go from 0 to negative infinity, which is how most people are going to say it. But remember, we have this thing down here that says we're going from left to right. So that includes whenever you describe what's going on here. So because of this, what we mean is we don't say that we're going from 0 to negative infinity. We say we're going from negative infinity to 0. So we're going to go from negative infinity to 0. So that's the interval on which this function is constant. All right, so let's try another example. So try this one. Try, say we've got a function going from, put it down here at 0, negative 1, and it's going to go over to 2, 4, and then over to 4, 0, and look like this. Bonk. Like that. All right, now again, I'm going to ask, where is this function increasing? Where is this function decreasing? And where is this function constant? Okay. Now remember, we're going to go from left to right. From left to right. So pause it if you will and try to solve this on your own. Otherwise, we'll just work through it together. So increasing, going to go increasing. This is where I'm increasing. I'm increasing from 0 to 2. I'm decreasing here and here. Okay. Now, so I'm going, the first part I'm going is from negative infinity to 0. And we're going to connect it with a union, because it's like our little guy going, I don't know, either one is decreasing, pick the one you like. So our shrug is our union. And he goes from 2 all the way down to where? 2 to what? you said 4, most people say 4. 4 is not the answer. Remember, it goes all the way down, forever and ever and ever. If you ever say forever and ever and ever, that means you're going to infinity. It's a little hard to see. So this is actually going from 2 to infinity. Okay? So don't be distracted. This is a decoy. This is a decoy point. They're trying to get you to say it. But think about it. If I put a little marble here, if I put a marble here at this point, it would keep rolling down. So that means I'm still decreasing. As long as my marble is rolling, I'm still decreasing. So I need to go not just from 2 to 4, but I need to go 2 all the way down to infinity. And of course, I'm not constant anywhere. So nowhere. Okay. So your book is going to start asking you questions like this. And, well, they're going to ask them funny. This is how I'm going to ask it to get started. I'm going to say, what point is the relative maximum? Another way of saying it is to say what point is the local maximum. And if you would still stare at me blankly, I would try again and I'd say, which point is higher than all its neighbors? So which point is higher than all its neighbors? So if you're looking at these points here, hopefully you're coming up with this one. This point here is higher than all of its neighbors. It's at the top at 2, 4. At 2, 4, it's higher than all of its neighbors. Another word for that is relative maximum. That's what your book's going to call it. You can also think of this as where the hill is. This is the top of a hill. Two, 4. All right. So I'm explaining it to you this way because your book solves it a totally weird way, and this is getting really complicated. So I'm going to do this again. Okay. So this is the way your book is going to ask you this question. It's going to say this. And in fact, here, let me make a little copy of this so we can still see it and talk about it. So you can do this on your paper easier than I can, because your paper is bigger than mine. My paper's little. Okay. So here's my little graph. So this is how your book is going to ask this question. Your book is going to say, or your online homework is going to say, determine the numbers at which f has a relative maximum. Then it's going to say, what are these relative maxima? Okay. Now, what it's actually saying here, this is a where, determine the numbers at which it has a relative maximum, and then determine what those maximum are. If nothing else, remember that this first question is always asking after an x value, or x values if you have more than one. And this one is always asking after the y values. So the idea is, well, first of all, let's go to the answer. The answer is 2. So I'm going to take this point that I found. The first one answers the where does it happen. The second one answers the what is the max. So the idea is, if you're curious, is that our maximum occurs at 2. So we go 2 over to get there. Oh gosh, that was a mess. We go 2 over to get there. So it occurs at 2, and the value itself is 4. So it occurs at 2. The value itself is 4. If that doesn't make sense to you, don't worry about it. It will eventually, if you really, really need to have it make sense. Otherwise, just think about it as the fact that the first one is the x values and the second one is the y values. So 2 and 4 in this case. Okay? So we're going to have another set of problems very, very similar, another set of questions. And I'm going to write them in my words. We'll talk about, I might ask you, well, I'm not going to ask you any of this because your computer's always going to be asking you. So what is the local minimum? Minimum. What is the local minimum? Or what is the relative minimum? Or what point is lower than all the other points? Can you hear Thomas in the background? What point is lower than all the other points? Or what is the bottom of the hill? Bottom of a valley. Bottom of a valley. We'll put it that way. Okay. So let's scroll up and look at our graph. Okay. So looking at our graph here, what would you say would be a local minimum, a relative minimum of an area at which we have a low valley, the point that's lower than all the other points around it? Hopefully, you're starting to focus in on this point right here. Right here, this point going on right here. That's considered our local minimum. All the points around it are higher. Now you say, well, this point over here is lower. Yeah, that's not the point. The point is this is a local. You know, like big fish in a small pond kind of thing. Like you're the smartest person, I don't know, wherever you happen to be at the time. If you make your number of people you're around big enough, you'll never be the smartest person in the room. But anyway, it just depends on who you're comparing yourself to. If I go pick up my kid up from preschool, I'm the tallest person there. That never happens in real life. Pretty soon they're all going to be taller than me. Anyway, what was I talking about? Local. Local min. This is considered a local minimum, and it occurs at 0, 1. So 0, 1. So again, your computer is going to ask you these questions in a really dumb way. So your book says, it's going to say, determine the numbers at which f has a relative minimum. Then it's going to say, what are these relative minima? What are these relative minima? So again, you're going to answer this problem the same way. Just remember that the first question, when it's talking about the numbers at which, these are the x values. And when it's asking for the actual minimum, that's when you're going to give the y values of that coordinate position, of that coordinate pair. You might have more than one local max, more than one local min. We'll look at an example of that in a second. So if we're answering this with the x values, we're going to say 0. And then we'll answer with the y values. What are these relative minima? 1. And that's what they're looking for. So let's add a couple of extra problems to this. Let's look at this a little bit more in depth. No, wait, I don't want to do that. We'll do it on the next one. I've had enough of that problem. All right, let's look at another example. Say you've got something like this. This is a much bigger example. Okay. I've got a point over here at -3, 0. I've got a point down here at -1, -2. I've got a point here at 0, -1. I've got a point here at 1, 0. I've got a point out here at 3, 2. Can you hear my dogs? And then out here at 5, 0. All right. So now I'm going to go all over the place with this thing. I'm going to go up and down and up So let's look at a bunch of questions. How's that? All right, let's look at where is this function increasing? Where is this function decreasing? Where is it constant? Let's see what we'll say. We'll say determine the numbers at which f has, and we'll try a relative max or a relative min. And that's my boy. And let's see. So we'll say, what are these? Relative min or max. What are these relative max and min? All right, so go ahead and get started on that. See if you can make some progress. Okay, so start off. I'll write this out because I want to. So where is this increasing? Okay, so where are we increasing on this function? Hopefully you've got us going increasing here on this line. But we're going to focus on the x values. So we're increasing from -1 to 3. And let's see. Oh, we're also increasing over here. We're increasing over here. So let me move this over. We're also increasing from, remember, -infinity to -3. Remember, we're going from left to right. That's a terrible arrow. From left to right. So we're going from -infinity to -3. And that'll get us. All right, now we're going to talk about where we're decreasing. And we're decreasing along here. So we're decreasing from -3 to -1. So from -3 to -1. And we're also decreasing from 3 out to infinity. Remember, don't get distracted by this. Get distracted by the decoy. So we're going from 3 to infinity. And where are we constant? We are constant nowhere. Okay. So we're looking at determine the values or the numbers at which x has a relative max and a relative min. So let's look for the relative maximum and see if you can find this. So our relative max, we're going to see a maximum here at 3, 2. But there's also a relative max over here. There's also a relative max over here. That's also a maximum point. Locally, he is taller than all of his friends. This is like me at preschool. I might not be taller than this guy, but at least I'm taller than somebody. So that's what we're looking at there. So our relative max, so let's write these, we'll kind of write these points out on the side. So your book is not going to ask you for the actual points, but we'll write them out so we'll know what's going on. And then the relative min, there's only one of those, and it's this one down here. So our minimums are, well, there's only one of them, -1, -2. Okay. So if our problem is asking, determine the numbers at which it has a relative max, remember these are all the x values. So the x values on our maximum are -3 and 3. What are these relative values? Those are the y values. So that's going to be 0 and 2. For the relative min, again, we're going to go pull off the x values first, which is just -1, and then the y values, -2. Okay? Now I'm going to ask a couple of more questions just to kind of pull it all together. So I'm going to make a copy of those. Again, you've got a big piece of paper where you can see everything, so I don't feel too bad for y'all. All right. Here we go. Nice, pretty brown. All right. So here's a couple of more questions. See if you can pull these out. What are the zeros of f? Pull these out of your brain. Figure out what these could be. What are the zeros of f? That's one of them. Try if f of x is 2, what is x? And what is f of -1? And finally, is f of -2 positive or negative? So take a look, see if this makes sense. So what are the zeros of f? So another word for zeros are the x-intercepts. Okay, actually I'm going to do these in green. So what are the x-intercepts? So remember, you come along the x-axis and see where we intersect. Okay, we got an intersection here, and here, doop-de-doop-de-doop here, and doop-de-doop-de-doop here. So there are actually 3 zeros of f. There's one at -3, 0. There's one at 1, 0. And there's one at 5, 0. All right, so if f of x is -2, what is x? Right? So remember, if f of x is -2, so this is your y value. So another way of saying this is, if y equals 2, what is x? So if y is 2, what is x? So we go look at our points. We want to find the point that goes here. So y will be 2. We need to find the point, whatever is going to be on there. So we look for something with a 0 in the x-axis. It's not here, it's not here, here. But it's right here. And it's the only one like it. It's right up here. So our answer actually isn't even 3, 2. I just did that so you could kind of tell what we're doing. But the answer is, well, what is x? When y is 2, x is 3. When y is 2, x is 3. Okay? Now we're looking at next question. What is f of -1? Remember, this is our x value. So when x is -1, if x is -1, what is y? So again, we're looking for something that looks kind of like this now. If x is -1, what is y? I'll write that back actually kind of like this. So if x is -1, what is y? So we'll go in here and we'll look and say, okay, well, where is the 1? So when x is -1, y is -2. So that's actually our answer going to be here. Now, don't let this last question throw you. It's really not meant to be weird. But the whole idea is this going to be positive or negative? When we're doing this, what we really want you to do is we want you to estimate. So we'll come over here and say, well, f of -2 is going to be right about here. So remember that anything down here on the underside is negative, because this is referring to what the y value is. And anything up here is positive. So f of -2 is going to be under there. So it's going to be negative. And that ought to be plenty to get you going.